Hello, everyone, and welcome to today's SANS webcast, Postmodern Web Attacks, Kubernetes Attack Matrix. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Moses Frost, Certified SANS Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Moses.
All right, thank you, Carol. Hope everybody here is doing well. So let's see if we can flip over to the next slide. Actually, let's see. Well, for those that I'm just looking at myself, make sure that I'm actually on the camera. So hi everybody, my name is Moses Frost, and I'm recording today, or at least I'm doing this webcast today from the Wooden Box. That's what I've been calling it now. So there's a few of you, I think, that are on the webinar that are probably giggling because you know the truth of the Wooden Box. But I'm in the Wooden Box. Some call it the outhouse, and it's always scary when we talk about this. But this is my current location for the pandemic, COVID lockdown, whatever you want to call it, as you know, as the world kind of is different right now. But today we're going to talk. We've been doing this series of talks called Postmodern Web Attacks, and it's been going on for about a year now. The idea was to start to talk about new architectures, new ways of doing web stuff, and since we've got so much capability now to do this remotely for everybody, we've taken our SANS at Night talk, and we're just basically giving it to you during a webcast format in an ongoing series versus it being a SANS at Night talk. For anybody that's ever been in the events, you know what those are. Without further ado, let's talk about Kubernetes. So first of all, who am I? So my name is Moses Frost. I just started working at McAfee, so you know, getting my feet wet. I'm sure there's going to be some social media disclaimer that I'll have to have, so I just kind of modified it. I teach at SANS. I teach on the red team side. I also teach. It's been a while, but I've taught on the forensic side of the house as well. Author 588, 642. So we could talk attack, defend, what have you. This is just my warning, right? This is the don't tase me, bro. So that kind of thing. All right, so what are we here to talk about today? We're going to talk about something called the threat matrix for Kubernetes. I just kind of wanted to make sure that everybody knew that that's what it was called. Very similar to the MITRE attack matrix. So let's take a look at what this is and how you can use it today, and how it's applicable, right? Why it's kind of interesting thing for us. So for those that are not familiar with MITRE's attack, right? The MITRE attack framework. So MITRE attack framework's been going on for a few years now. I have to say every week that goes by, every month, every whatever, we're seeing more and more adoption of the MITRE attack framework. And for someone like me who's done red team for a while, or that has been on the attacker side for a while, it's always difficult to justify your existence at times to people, right? And I've taken over the years a very analytical approach to this, right? So, you know, pen testing in my older definitions was very equivalent to test-driven development on the software side, right? So it's like you're testing for software bugs. How are you not testing for basically architecture, security, bugs, right? What is your system working like, right? And that had some impact, but I think it was harder to explain to folks why the red team folks were needed, right? I think that a lot of businesses always thought of testing as a nice thing, but unless they were very focused, it wasn't always a must-have, right? I think we're starting to see that change now, but that was kind of the way that it was. With something like MITRE ATT&CK and some kind of platform like MITRE ATT&CK, if you really think about what it's done, it's taken the tools and the techniques and the things that make an attacker group, an actor group relevant in your environment, right? So instead of looking at the types of executables, the types of IP addresses, the stuff that is the easiest to change, we'll show that in a minute, it looks at the hardest things. And what's really nice is that it's really a loose kind of specification for what attackers do, right? That's what a MITRE ATT&CK basically is, right? So if you think about like when you write JavaScript, you write Python, right? Those programming languages have a specification, right? And the specification describes how the language interpreter should run, right? Or what it's doing under the hood. Well, MITRE ATT&CK is basically the hacker's spec, right? It's kind of like, okay, this is how they're breaking in, right? This is what they're doing to break in, right? It's not exactly the tools that they're doing. It is what it's the what, right? So this is what it looks like if you've never seen it, right? So you go to the MITRE webpage, you go to the ATT&CK webpage, this is what it looks like. It basically divides things up by, I hate to say phases of an attack, because there's kill chain, which is the Lockheed Martin kill chain and all that. It's a little different, right? This is more like kind of like steps in the attack that are just a little different, right? So it says, okay, there is a whole category of initial access into a system, and that initial access into a system has these defined types, right? And there's more. I've actually just did some cutting. I chopped it off at the bottom to make it fit on the slide, but there's a bunch that are in there. And now in the newest version, there's even sub definition, like sub, what kind of phishing and that kind of stuff, as an example. So they're almost like sub techniques, if you will. And what's really kind of fascinating about this, right, is that not every single attacker will cover all the techniques, and that's perfectly reasonable once you see the breadth of things you have to cover. And not any single vendor will protect against all the techniques, given that there's such a breadth to cover, right? So I think it kind of cuts both ways, but it gives us all the same language to talk about attacks, right? This is what it does, right? So it kind of says, okay, there was a just an example. They used a cert util, and cert util called a PowerShell Cradle, right? And then you could say, okay, well that's an example of, I don't know, persistent or execution or what have you, right? An execution step, right? And so now if you are a EDR tool or you are a antivirus tool, you can actually go in there and say, yeah, we see this and we can map this to MITRE ATT&CK. If you're a red team person, you can say, yeah, I can actually simulate, or not simulate, emulate what the attacker is doing, right? It's not exactly a simulation, it's more like an emulation, right, of what they're doing. And we could kind of talk in those defined terms, which is nice. What was more interesting was I was talking to somebody, I was actually talking to Katie Nichols back when she was at a lunch at a SANS thing. She was one of her first times teaching at the event, and she was still working at MITRE at the time. And I met her and I told her how much I really enjoyed the ATT&CK framework, and she gave me like a 5-minute history of it, right, which was basically really interesting to go listen to the history of ATT&CK. But I asked her, so what about web? What about web? Like what do you think about like web attack or whatever? And she goes, we really didn't want to tackle web when we did MITRE ATT&CK. We were really focused on Windows and like desktops and endpoints or servers. We didn't go into applications, and I can see why, right? Like when you start going into applications, it gets really gnarly and it almost has to be a different matrix, right? And I kind of left it alone. I didn't think anything else of it. I was like, okay, that's fair, right? But also at the time that we were speaking, MITRE ATT&CK really wasn't as well known in the industry as it is today, right? This is going back a few years. It had just come out, and it was really really interesting. And over the years, it's grown. It's become very compelling way for us to talk, which is great. And so now we can frame the conversation, right? So it's not focused on web, and it's not a top 10 list, but it's how an operator or a group functions, right? That's what MITRE ATT&CK is. Okay, great, I get it. Why are we spending so much time on MITRE ATT&CK? Well, there's people on here that may have never seen it or may have never seen my viewpoint on it. However, there is one more thing I want to talk about, which is why it is so important to frame the conversation. And that is MITRE ATT&CK works on technique, right? So it says I have a technique, I do the technique, and for me to change, if I've got an operations group that's been highly successful, I have a certain set of tactics, techniques, and procedures that I do, right? These TTPs. And so these TTPs for a actor group are the hardest things to change, right? And you can argue that writing code is harder. So the tools should be maybe harder than the TTPs. You can make that argument, I guess, all day long. And there's actually a news article where the military in the U.S., and I'm not sure which branch of the military, I forget which one it is, maybe it was the Army, but they basically, or some CERT or whatever, they started to post into VirusTotal nation state malwares, what I think they were saying, or at least they were claiming to do so. And they haven't released all terribly much that I could tell, but the one of the more interesting ones that they made a splash about was an actor group that may or may not have been tied to North Korea. I'm not sure if that was the case or not, if that ever was fleshed out or not. But they basically put into VirusTotal the proxy tool, right? And if you think about it, like a proxy tool is kind of a boring thing to write. It's not their attack framework. It's not their implant. It's not their whatever. It's just like a core infrastructure piece, but it just so happens to be random. And just by ripping out like core infrastructure, like proxy, from that one particular actor group and putting it in VirusTotal makes it really hard for them to retool, because now they're gonna have to rewrite a proxy, which is just like a boring thing to do. It's like a boring, monotonous exercise, and so it can be challenging, right? But all the stuff at the bottom is really easy to change. Like I could change hashes, I could change IP addresses. You could burn down domains, and especially like if you look at the way that people build C2 environments today, all this stuff is automated. It's all like really quick. Network and host artifacts, you probably burn that too. But when it comes to TTPs, changing the way you work, super hard, super hard. And so that is the reason that MITRE ATT&CK becomes interesting, because now I can map a group to their technique, which is fascinating, right? And so here is how you would map APT29, which is a Cozy Bear, I guess, to MITRE ATT&CK, right? So you can actually go, and this is an example, like, hey, they use spear phishing, and as part of spear phishing, they run PowerShell, run DLL32. They use the accessibility features of the system to get persistence. They use the accessibility features or just bypassing UAC to get PrivEsk. They bypass UAC. It's obviously it's a defensive evasion. They use pass the ticket. They use domain fronting, and so on and so on and so on. And you can see that they kind of are using a subset of these techniques in order to gain this attack foothold, right? And so for them to change all this stuff, right? Forgetting not some of it, all this stuff would be kind of hard, right? So you can start mapping actor groups over time. You can map them even by campaign if you really think about it, right? So at this point in time, they were doing X, and at that point in time, they were doing Y, okay? So it's really interesting to kind of see this visually on the map. Now, I want to take a bit of a detour on this, right? So I wrote a class last year. It's the cloud pen testing class, which is Sec 588, and I started thinking about development of the class back in the summer of last year, so around this time last year. And then a few months ago, we pushed it to production. And one of the things that we wrote in the class in the Cloud Native Day was Kubernetes, right? And we knew back then that we couldn't spend a day on Kubernetes. We couldn't spend a week. So we had to spend a very small sliver of time on Kubernetes. We spent a few hours really, but we did talk about throughout the day, throughout the week, and even in those little bit of time, we talked about things like executing code in the container, building new containers, remote code execution, backdooring containers, what a host mount is, what Privask is, how to do secrets, how to do app credentials, how to do kube API, talk about SS metadata, right? So we started talking about all this really gnarly stuff in the class. And throughout the week, we're playing with containers and host mounts and Privask, and we're building up that tool chain, right? And so we did this with the idea, or I did this with the idea of, if I want to take a cloud penetration testing class, what would I want to see, right? And then eventually, maybe we'll make it a more advanced class, and so maybe I should write a ton of it in there. And if I have to make it more advanced later, I certainly can. I could, carve out pieces of the class, or who knows, right? We didn't even know if people would take the class, because cloud pen testing, it sounds pretty crazy. It's cloud, but it's Kubernetes, and would people enjoy it or not? Anyway, so we wrote it this way, and I wrote it by the viewpoint of a site reliability engineer. So if I wanted to take a site reliability engineer and make them a pen tester, or vice versa, kind of what would that look like, and what would they need to know, and things like that. And then back in April, there was a Microsoft article, but April of this year. So we released the class in March, and a month later, I see this blog post from Microsoft. I had no idea that this was coming out, because I've had Microsoft folks in class, but we've never talked about this. And it's the Kubernetes threat matrix. And their idea was to take the MITRE ATT&CK kind of commonality, right, the spreadsheet format, and apply it to Kubernetes. And I'll explain why they did this in a minute. It makes a lot of sense. But if you look at it, we started looking, I was like, wow, they've actually put down all the steps on how to do basically a pen test, if you will, or an attack involving a Kubernetes cluster, or really any kind of container cluster. But in this case, Kubernetes being universal across all the platforms, makes sense that it's Kubernetes. And so, you look at this, and you're like, huh. So they have initial access, they have execution, they have persistence and Privask and evasion, right? And it starts looking very similar to the MITRE ATT&CK matrix. And I was thinking, is there anything that was even missing out of the MITRE ATT&CK matrix, or vice versa? Is the MITRE ATT&CK matrix missing any of this? And for the most part, all of these columns line up. There is a few that are different, right? So there's no collection column, right? So there's credential access and discovery and lateral movement and impact, but there's no collection, there's no command and control, there's no exfiltration, and there's no impact. And to me, those are critical. Like, I would actually put those in. That would be my advice to Micro. And I don't know if it's because it's a registered trademark, or I don't know why they haven't done it. But to me, I would do that, because there are things, even command and control wise, that we could do on a Kubernetes cluster. And but we looked at this and I said, okay, cool, let's talk about each one of these things, right? So we have initial access, where it's funny, I looked at all this, I think we cover almost everything in class, right? That was kind of crazy. I think I even listed out, like, what is it exactly that we covered? I said, yeah, we do a lot of this, right? And even the kube config. But if you look at it, right, you've got people leaving cloud credentials all the time, right? So, whether it's a Kubernetes, and if you're not familiar with Kubernetes, I could expand a minute, but Kubernetes dashboard, the dashboard it should be authenticated. You should have a certificate or some other mechanism, some kind of cream material, but you could not. Right? You can actually have it exposed without a username or password. And that's happened to big companies before. And you could have it behind a basic authentication, which I don't know if you know, but basic authentication is brute forceable, right? It's just basic authentication, like extremely brute forceable, or compromisable, right? Depending, right? Or you could actually backdoor images in Docker Hub, as an example, and people have done that, right? So in other words, it's not the Mongo database, it's not MongoDB anymore. it's MongoDB with a Cyrillic O or a 0 or something, right? Or it's the Moses version of MongoDB Docker container, right? And if you just so happen to use that one, it could have a backdoor, right? And then there's also things like execing inside the container. And so, it's a Linux container is an execution environment. It has a shell. It has all the stuff that you need theoretically that Linux has. Without a couple of, I will give you that it doesn't have maybe all the binaries, but it has the ability to exec, right? So you have all that. People have backdoored containers, or worse, you can actually build a container that can write out or that can mount the host slash, right? Also, privileged pods and cloud resources. You could even do things like things that I hadn't even thought of, right? You could totally do certain things, right? And you have the idea of like, connect from a proxy, right? We'll talk about this here in a minute, or listing the Kubernetes secrets, right? Or even just this is going to be fun. We're going to talk about that one, the Kubelet API versus the Kubernetes API, or the instance metadata, right? If you're running in Amazon, right? Super dangerous. Or just like once you're in the container, all the stuff that you could do to laterally move, right? And what's really, so this is a great way of describing an attack, specifically describing an attack that happens to impact you as the, as the Azure Container Service or Azure Kubernetes Service owner, right? Because Microsoft is going to have oversight over some of these container clusters, you would imagine if it's running EKS, and they may have to figure out what happened. Now, the things that I didn't cover, these were like, these were things that I was like, I guess it's true, right? Persisting through a cron job, like Kubernetes has the ability to run cron jobs. If you don't know that, it does, right? And so putting your, putting your backdoor back in, right, through a scheduled task, when it shouldn't be in there, right? Or clearing out the container logs, right? Or deleting the Kubernetes events, right? Or just having pods and containers that look similar, right? Like the pod of the container, like having two Nginx containers, right? Or just like accessing the kubelet itself. Like, and I sort of, I was explaining some homework that I did, but accessing the kubelet itself could be kind of great. And even just accessing the tiller endpoint would be interesting, right? If you've never done that. So there's all these like new things that I was thinking about, like, oh yeah, I guess that is another execution step or execution point, right? So even somebody that starts to become intimately familiar with this kind of cluster stuff can find new and exciting ways to kind of go after something like Kubernetes just by having access to a matrix, right? Where people could share, add, etc., right? So that brings us to this. So you can look at the data on this, right? I had to, I was talking to some folks last week, and we were talking about, what are we going to do for this webcast, or maybe before last week. And I said, I want to do something on the Microsoft attack thing that happened with their workflow, with their workloads. And so Microsoft had actually put a blog post a few weeks ago in May. So after the Kubernetes attack matrix, they put out a blog post, and the blog post was basically around the crypto miners, in detecting crypto miners, right? And then it turns out that what they were really referring to was this research. So I'm going to explain this research, and it's kind of interesting, right? So here's what it says inside of it. It says, during April, this is when they released, remember, this is when they released the attack matrix. So maybe there's a causality there, right? Or something like this. But it's basically during the month of April, we observed a deployment of a suspected image from a public repository on many different clusters. Okay, so I guess somebody had put into their Elastic Kubernetes Server clusters, many clusters, a image called DDS FDDS. Like basically, if you don't know what this is, right? This is somebody mashing ASDF on the keyboard a bunch of times. So DDS, FDF, SAA, DFS slash DFS DF, right? Version 99, right? Um, and by inspecting the image's layers, so what does that mean? That means if you know how a Docker container works, right? It's basically something called overlay FS, and inside of overlay FS, or that's what it uses anyway in the Docker version, and maybe the Kubernetes version they use something else. But if it follows the Docker standard, they use overlay FS, and every layer of the every time you make a change to the container, it adds a new layer to the actual file system. So if you go into var lib, wherever your Kubernetes is running or Docker is running, you can actually go into these MD5 or SHA-256, whatever they are, SHA-1 hashes, right? That identifies that layer, right? And so you can see the file system, execute file, etc. And in one of the layers, they realized that it was running an XMRig miner. So once again, owning up containers, right? Just to install crypto miner, right? And it's really funny because, who knows what's running? So first of all, Kubeflow, what is it? It's a machine learning Kubernetes environment, kind of like a competitor maybe to Google TensorFlow, although Kubeflow is like open source, you can run it anywhere. So Microsoft runs it as a service. So you can run a Kubeflow service in the Microsoft Azure cloud. So that's how that, so first of all, when they said they were looking at it, it was probably because what they're looking at is the Kubeflow service containers or clusters that are running inside of Azure that are basically services. So they have oversight over those services to make sure that those services are running correctly. So that's what happens there with that. So with that said, the first question was, is Kubeflow vulnerable, right? Because if you've got a bunch of clusters running Kubeflow and they each have crypto miners installed, like, is it vulnerable, right? Is there an application vulnerability that's being exploited? And the answer is no, it's not that. It's actually quite silly. And so Kubeflow has a dashboard. It's kind of like the Kubernetes dashboard. And Kubeflow dashboard is basically exposed through a CNI. Now, I know that for some of you, you may have never heard of what a CNI is, but it's basically a container network interface, right? So Istio is a container network interface, and the idea behind Istio is that you are, it's kind of like running on top of Kubernetes or running with Kubernetes, right? So Istio, so Kubernetes actually doesn't ship, it can, but it doesn't technically ship with a network stack. So imagine you run Kubernetes, but there's no networking, right? So how do you get things to work? So you have to bring your own networking, and Istio is one of those projects. Anyway, however, what the people were doing is that they were taking this dashboard and opening it up to the internet because they didn't want to access it with something called the proxy command. So for those that have ever taken like a network, like a 560, 660, one of those classes, you know that you do tunneling through Netcat, right? So Kubernetes does this, right? You basically type kubectl proxy, and it basically turns on a tunnel, like a port forward, if you will, to the remote Kubernetes environment, and it port forwards port 8080 and whatever the dashboard port you want. And so that's a secure way of doing it because you're opening a tunnel. Well, for some people who don't like that idea, this is what they're doing. Now it gets even more brilliant because this is where I think this is where you start to realize that there are people out there that are doing some pretty interesting things in the world of information security, as well as people that are just machine learning people that do some interesting things, right? And so this is like a confluence of interesting, because when I saw this, I kind of lit up like smiling, because I was actually following for a while the folks out there like Cyber War Dog, and he did a thing called the InfoSec Jupiter or InfoSec JupiterCon, something like that. But the idea was it was basically a information security conference on YouTube, very similar to this information security conference idea, right? Something like this, right? Where everybody gets on and they kind of do the thing. And the information security conference on YouTube was basically I mean, for the most part, it was uh, a conversation around how to use defensive techniques, right? Threat hunting and this and that, but using a Jupyter notebook to do it, right? And so if you don't know what a Jupyter notebook was, right? It's basically what happened to IPython, right? So if you haven't ever seen IPython, I ran into this about, I don't know, 10 years ago, or maybe a little, maybe 8 years ago or something like that. But IPython was basically a shell. So you have, the bash shell, you have the C shell, right? And you have K shell, ZSH, fish, right? So that's what IPython was. And you run into it, or I mostly ran into it because I was looking at how to use compute clusters. And so for scientific computing and for compute clusters, IPython was used. And what you could basically do was, run operating system commands, but also run Python in your shell, right? So that you could do ls and everything else. Well, some people thought, that they were such Python nerds, I guess. I'm a Python nerd, but Pythonistas, that they would actually just run it as a shell. Well, I had forgotten about IPython and started noticing IPython making a resurgence a few years ago. And really what they were doing was this, the Jupyter Notebook. And so the Jupyter Notebook, what it does is it's basically a way for you to do, I should probably have a better picture of this describing these things because you'll see why my face lit up here in a minute. Just discard this. So Jupyter Notebook looks like this, right? You could probably write a website on a Jupyter Notebook, but it basically probably looks like, I don't know, probably it looks like this, right? So you write Python inside of the notebook, right? And it builds graphs and plots and science, it does all the scientific work. Or you could use it for threat hunting, like some of the people use it, right? And you literally can go in here, try it in your browser, right? So try what they call a classic notebook, right? And you'll see that it uses a tool called Binder to do this, right? And the most interesting thing about the Jupyter Notebook is that you are writing Python, right? So you're writing steps in Python as if you were in the command line. And you can see why a threat hunter would want to do this, right? Where they would want to say, oh, yeah, like if I can write this in Python, and when I write it in Python, I can run it and it will execute the command and it will give me the output, right? And you could see why this is kind of interesting, right? And if you wanted to actually, like, add an area, you could say, for I in I don't know, words, or actually you can say like words is equal to 1, 2, 3, 4, 5. That's not words or numbers. Sorry. And you can say for I in nums, print I, right? Enter, right? And you can run this, right? And if you hit run, whatever. Oh, sorry. Print. Yeah, that was. Oh, sorry. Python 3. Sorry. So you can say, okay, run that, and then it would do this, right? And this is what a Jupyter Notebook does, right? It actually is a web interface, and the kernel is Python or Ruby. It turns out now I'm in love, actually. Now that he said Ruby, I said, oh yeah. And it basically does all these commands, and you can go back to your notebook and go, oh, you know what? I was looking at, I hooked it up to Splunk, and I was like looking at APT32, and I wanted to know more about it, so I did all these Python queries, to go to Splunk and all this stuff, right? And you can see that this is basically remote code execution. That's what it is, right? Right? This is like remote code execution, but like to build a web page, right? And you're like, all right, whatever, that sounds cool. And so I lit up like a Christmas tree. And why am I talking about this? The Microsoft article was explaining how this ASDF thing, right? ASSDF, this whatever container, basically was gives you two options. Use a custom image to deploy a Jupyter Notebook. So in other words, point it to your dirty container and have it execute as a notebook, right? Or a backdoored container, or use the Jupyter Notebook itself. And I'm like, what? Use the Jupyter Notebook itself? And they give a screenshot and what it is. And this is brilliant. Kudos to the attackers for figuring this out. You can import the Kubernetes library into the Jupyter Notebook, write a pod, like literally write an actual description of a pod, read in the secrets from the actual underlying OS that the kubelet will talk to the actual Kubernetes API. And if you have enough permissions, go ahead and run the container based on this pod specification that you built. Oh man, brilliant, right? Using a Jupyter Notebook to literally do Kubernetes execution. I was like, bravo, right? That is just brilliant. And now you know why I think it's brilliant, because it's actually a Jupyter Notebook. It's just like, wow, right? And so they published this, right? And so now, if you wanted to emulate the CryptoMiner attacker group that owned up all of these, Azure Kubernetes environment, it's like brilliant. It's like you have the exposed dashboard, which leads to a new container, which leads to a backdoor container, which has which uses the container service account, which hijacks the resources. It's like, oh, that is just, hey guys, that is brilliant, brilliant job, fantastical, right? And so, it could be so much worse. Like, you don't know what data sets these environments are running. It could be proprietary data sets, right? It could be so much worse. If the worst that happened to you was a crypto miner, I would say consider yourself lucky, because it could be so much worse. And so this is why it's valuable, right? Because now we have a reference, a referenceable or a reference area that we can point back to that says, if you want to emulate an attack, well, this is how you would do it, right? Now, I did some extra credit homework because I was curious. I decided, hey, how bad is this, right? How bad is this? Now, I mean, I could tell you anecdotally right now that if you go to Shodan and you look for port 10250, so 10250, 10250 is the kubelet API, right? And the kubelet API shouldn't be exposed to the internet, granted. But if it is, it should definitely be exposed with a key material of some sort, right? You shouldn't be able to authenticate it. Now, the problem with Shodan is not a Kubernetes scanner. Shodan is a port scanner, so it doesn't go to the URLs in the kubelet that would return information. So it's not going to tell you how many of these are vulnerable. It's just going to tell you that there are ports open and that they can attach to it. But yeah, 100,000 IP addresses is what I found. 100,000 on port 10250. That's a lot of Kubernetes, clusters out there, right? That are exposing the kubelet API, right? So that's kind of shocking. And most companies will have more than one cluster, right? You got to think through that as well. Now, I also did a Google Dork, which, I guess you can see the Google Dork now. My retraction didn't work. Well, I retracted enough. I didn't want to expose all the machines out there. But yeah, there's like if you look at this, right, this is the traffic Google Dork. Right now there's 9 results, right? This is another dashboard. It's another dashboard where we don't want to have people exposing traffic out there. So, this is another section. It's like, dude, what are you doing? Why are you exposing dashboards, right? Now, 9 is not, it's not terrible. It's not 100,000, but it is 9. And so that's, now whether it's 9 important ones or not, just stop. Just people need to stop, right? So stop doing this stuff, right? It's not a secret, right? Anybody can find it. So what do I do? What do I do with all this data, right? So first of all, MITRE ATT&CK, it's pretty powerful, right? Because it's something that you can program or design to, right? It's a spec. Now, hopefully, we can start taking things like the attack matrix that Microsoft has created and either extend it, expand it, do whatever it takes to actually start mapping this out. So hopefully it starts to get traction, because that way, when you're in a EDR, when you're in a Kubernetes specific security project, you can actually see traffic and map it to something like that, right? Where you can say, this is a backdoor container, this is persistence, or this is execution or initial access, right? And that way you can actually start to tag things in their appropriate technique, so that you can start looking for actor groups and get more intelligence that way. That's the idea, right? That's why you'd want to bring awareness to things like this. Now there is another tool out there that came out just for the last few days. A few days ago, it was announced, and that's called Starboard. And so I've been a fan of the Aqua Security Cube Hunter for a while. Insofar as the Cube Hunter is very simple and dumb and looks for very simple, dumb on purpose, right? Simple things, right? It's not a pen test. It just looks for, are you exposed as an API? Do you have things like I don't know, insecure tokens? Can I read etcd? Can I execute? How are your groups, right? Like just the basic one-on-one stuff where you can actually interrogate the API and get an answer. And so the same folks at Aqua Security actually wrote a tool called Starboard. And Starboard, it takes the CIS benchmarks for Kubernetes. It takes the Cube Hunter. It takes a couple, like 4 tools right now, and it runs it against your environment and comes back with security issues, and basically puts it on the dashboard, or can put it on the dashboard. And it looks for, like, hey, are your dashboards exposed? Have you hardened your users? Who's got permissions? That kind of stuff. Because if you've ever looked at Kubernetes, it is actually a very, 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 very complex system. It's very powerful, but it's very complex. And it wasn't like it started out its life thinking, I'm going to secure containers. It started out its life thinking, I'm going to make it so that operators can keep things running. And so that's not wrong. It's just that when you start off with that mentality, like that MVP mentality, you have to start baking security back in. So while it's got a lot of good security stuff in it, it's not full. I mean, it didn't even have RBAC up until maybe a year ago, right? And so you gotta think through how your Kubernetes is set up and how it's meant to run, and you gotta think that it's for operations, right? So having tools like this helps greatly. So before we end, I saw some Q&A. So 2 people asked me a question. Is there a link to the Kubeflow article? Yes. So I always give out the slides, and I always give out, I think there was a bit.ly link. Did I not give out the bit.ly link? Oh, I'm sorry. Let me give you a link to the blog post. I'm going to put the link on here just because I think you should have it. Copy this link. Discard this. I'm going to put it right here. Oh, that's bad. That's not what I wanted. Let's put it, I don't know. Let's reset the layout. No, that's not right. Let's just put it, I'm going to paste it right here. Kubeflow. And move this down for y'all. Right, that way you could get it. Carol, you may have to reprint it or what have you. But I'll also put it in the chat, but the chat goes away.
You want to send it in the chat? Oh, I see it now. I'll send it to the group.
Yeah. Okay. But the chat does go away. Yeah. And then, are there any other questions before I since I'm already answering questions, are there any other questions? and move this down for you all. Oh, Carol put it out there. Yay! Thank you, Carol. By the way, if you I saw somebody raise their hand, but I'm not sure if you're raising your hand because you want to ask a question. You could use a Q&A panel. So if you don't know how to use this, you could use a Q&A panel to ask questions. Yeah. I don't know. All right. Well, I mean, I see a few familiar faces out there, so you know, thanks everybody. If you have any questions for me, I'm Moses Frost. I do this quite often. I spend like every 2 weeks lately, but it's probably going to be more like a monthly thing. We normally do this around not infrastructure security like this. We normally do things around web attacks. So if you go to the SANS webcast history, you will find previous talks where we talk about vulnerabilities in gory details, things around like, what happened with SaltStack, what happened with Azure, where are we today with Python and with Python Flask and templates. And so if you have any questions for me, happy to do that. Normally I talk about really things that really interest me as well, things around multi-language container exploits and the like. Oh, and I did get one other question. Is there any further links on using the Jupyter notebooks in InfoSec or on the conference? Yes. It's the InfoSec Jupyterthon. Let me give you that one. I will put, Carol, I'll send this one to the entire audience because now I know how to do it. The link is in the chat window, but basically I will put it, let me put it in here as well because, people seem to be asking for some links.
Yeah, I do see it in the chat window.
And if they watch the web.
Yeah.
Yeah. So this was the Jupyter Notebooks InfoSec JupyterCon. And if you're a pen tester, then I would also say that you would like to know that Red Elk is starting to integrate this into their Red Team Elk stack. So there's a lot of research happening here. So there you go. And I think we've answered all the questions in the Q&A panel.
Yes, that's all I see.
All right.
Great. Well,
okay.
Oh. Well, thank you so much, Moses, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Yep. Thanks, everybody.